Of course, coming to fiber optics, the power will be in the order of milliwatts, and the dimensions is very small. And instead of air in the metallic waveguide, here you have the glass as a core and a cladding. They are all glass mediums. It is a solid and it has minimum signal distortion. And the most important aspect is it has very high bandwidth and it has very low loss. And it has both EZ and HZ. So in the coaxial cable, we said the fields EZ or HZ. Here we say EZ and HZ. Hybrid mode is possible. And you have two types of guides, single mode and multi-mode. So coming to the circuits or the system where it can be applied, as I told you, the frequency and energy flow is very important consolidation. In the case of low frequency, the application of the system is a circuit, electronic circuit, where the energy flow is inside the conductor. In transmission line, it is outside the conductor. The frequency is VHF. In coaxial also, it is outside the conductor, in between the two conductors. In waveguides also, you have outside the conductor. In optical fiber, it is inside the glass core. Right? These are the differences between the various frequencies. The energy, as I told you, voltage is accumulation of electrons, current is flow of electrons, radiation is oscillation of electrons. So these important physical phenomena you should always remember. So voltage, size of energy packet per electron, current is number of electron packet flow per second. So current is nothing but dq by dt, rate of change of carrier or electron flow. The rate is used here, whereas voltage, it is the difference. Energy flow per second is V into I. So in circuits, the power is given by V into I. The medium is conductor. In transmission line, low frequency, high frequency, waveguide, optical fiber, all these cases, the power is given as E cross H, where you introduce electric field and magnetic field. Whereas in a circuit, it is inside the conductor and the medium is conductor. So energy flow in transmission line is TM mode, coaxial line TM mode, waveguide is TE and TM mode, optical fiber also TM, TE and TM mode. So we say the power is flowing through various modes.